Thank you for coming today. Today's talk will be PBS Kids 24/7, live linear from the ground to the cloud on a public media budget. Let's see if this works. Perfect. So I'm Mike Norton. I am a cloud architect with PBS, specifically the PBS Digital organization. I'm here with Bradley Andrews from StackPath.
Hi, I'm the product director for CDN and delivery products at StackPath.
Great. So today I'm going to talk about the 24/7 that we set up for kids. I'll start with a quick introduction to PBS. You've probably all heard of PBS, but you may not know everything that PBS does. We stream video. Specifically, over the past 10 years, it's mostly been VOD and MVOD, which is membership video that we provide for members like you. It depends on the season as to how much we do per month, or rather the part of the season. Around January, when we're streaming things like Downton Abbey and Victoria and Sherlock, it can get up into the 30 plus petabytes a month. But we average about 20 petabytes a month of content. And so how do we do that? Well, we started out by building a video CMS about 10 years ago. Launched our third version of that recently. We're essentially a B2B organization, but also B2C. So the stations run PBS. You probably know your local PBS station. That's not us. We're PBS. The stations are part of PBS. And at PBS Digital, we're a product development organization that builds a video platform to serve those stations. It wouldn't make sense for the 160 stations to each build an Apple TV app and an Amazon Fire app and so on and so forth. So our video CMS is used by over 150 stations, scores of producers. It's basically dozens of apps that are on mobile OTT, which is where we see our best engagement. And then via those platforms, we directly serve the users, but at the behest of the stations. And we use localization to station brand the experience for the users. But that's just one of our 3 tiers. We also have website CMS products and tools, so a station can build a website through a bento builder we've created for them. They can embed live TV schedule widgets, basically helping the stations to do what they need to do for their web experience. And then we also have an API layer, which the stations can also use to be able to grab TV schedules, authentication services, and all that kind of thing. So we're going to talk about a specific problem we had, though. So PBS Kids is the most trusted kids programming brand, but we were losing exposure to cable packages. And more importantly, we weren't reaching the audience we cared about the most, which is underserved communities. So these underserved communities can't afford necessarily to go out and buy a large cable package to get this content. And in fact, there are some parts of the country where if you're not getting the cable package, you don't even have an option of over-the-air. In West Virginia, parts of West Virginia, they don't even have that option. So we wanted to have a new presence. And so the plan was to create a new kids channel that stations could take off the satellite and multicast out on their broadcast networks. When digital channels, you've got multiple slices of those digital channels. They'd be able to broadcast that on their own. So just give that to the stations to broadcast over the air. We wanted to reach children and households that couldn't afford cable satellite, but also offer this as part of the bundles we can give to cable satellite providers. And we wanted it to be fully packaged, so the station could just literally add it to their streams and go. But one of the things that made it complicated was that we wanted to be able to provide a way for stations to put a 65-second avail at the end of every half-hour programming. So they could basically customize the experience so when people are watching this, they can see that this is from WNET or WGBH or whatever station. Over the air, that's easy. They take the satellite feed in. As they're broadcasting it over the antenna, they just overlay their content for those 65 seconds at the end. But we couldn't really, wanted to do that for digital as well, for streaming. So that needed to go out over all of our platforms. So we had web, iOS, Android, Windows, Fire TV, Roku, Apple TV, Android TV, Chromecast, Xbox One. You name the platform, we're on it. So a little bit about our kids' platforms. These numbers are actually a few months old. We've had over 18 million downloads since we launched 6 years ago. You see 1.5 million active monthly users on iOS, almost 1.5 million on Android, 1 million on the website, and a number on OTT as well. So lots of active users, lots of engagement, and we wanted to provide this ability to do localization for the member stations and also time zone shifting, because we have stations across 6 different time zones. we wanted to make this so it wasn't, when you go to watch at 8 a.m., the schedule would hold. So if you watch Curious George at 8 a.m., that's also going to show at 8 a.m. Central, Pacific, all the way across. We wanted to give them an ability to put this interstitial content in for 65 seconds at the end of each episode, but only play that ad pod if there was one scheduled. And so for stations who didn't want to do anything, they would just get a sort of a generic PBS Kids content there. And then also being able to do branding client side for the logo of the station and so on and so forth. So we started to spec out what it would cost for 160 plus member stations to each create their own stream of content and send it back to us. So the idea initially was we will send this out over the satellite, the station can do what they want to do to it, and then send it back over to us to stream, which would mean 160 primary streams, 160 backup streams, have to have robust ISP connectivity at every station, which most stations are just running their local Comcast, Verizon, whatever ISP, and they may not even be paying for the business grade. They have dial-up, not dial-up, but they've got just ISP internet. So it's going to be a lot of complexity, a lot of fragility, and a lot of money, which we don't have. People will often ask us, when we were speccing this out, we had a couple of vendors asking us, what's your business model for this? What's the ROI you're going to get per viewer? And the answer was nothing / negative. We have to pay the CDN costs for every view of our content, and we don't get any money in return. This is something we do as a service. So we went back to the whiteboard, and we tried to figure out how we were going to pull this off for more than 100 stations. And we had an idea, which was more than 96% of the content is the same across all the station streams. The only difference is the time zone delay and the 65-second avail for every half hour. So trying to do this with a separate feed for every single station was going to just be incredibly wasteful, operational nightmare, and too expensive. So the solution was dynamic HLS packaging. And I'll go into that a little bit here now. So HTTP live streaming it's not really streaming, it's a pseudo streaming protocol. What you end up having is, it allows for adaptive bitrate switching, multiple audio tracks, easy delivery through standard HTTP CDNs, and it's the protocol that Apple pushes for, is the only one they allow on their devices, so it's become adopted everywhere, and so that's what we use as HLS. And so the way HLS works is you have a master playlist, which is basically a text file that just points to playlists for each bitrate. And the players are able to basically choose the bitrate they want for the, based on how the player, the internet connection is and so on and so forth. And it will dynamically change between that. Those playlists then are a playlist of chunks of video files. And the player just knows to grab 6-second chunks of video and play them seamlessly. If you're ever watching, streaming something, and if you ever see the picture kind of pixelate for a couple seconds and then sharpen back up, that's your player doing the right thing, which is instead of just stopping and saying, I'm in a bad place, it says, shoot, give me the 192 kilobit per second media playlist. I'll play those chunks until I'm good, and then I'll go back up to what I can support now. So it's basically a playlist of playlists, and those playlists are of small TS chunks. And so so those 6-second segments, and the way it works with VOD, which is what we had done for years, was you got one master playlist, which then had the multiple bitrate playlists, and they had a list of every TS file for the entire show. With live, we're showing basically a window of the most recent, what should be playing right now. And so you get this live live playlist. And so, for example, when you're playing live on EST there, you've got there's the 6 chunks that are maybe right now for live. And so it's a sliding window. The good news is we keep about 8 hours of the actual media segments in S3 and also cached in the CDN. And so we decided to start basically dynamically generating the playlists so that if Curious George played at 8 o'clock, we've already transcoded that. The chunks are already there. They're sitting in storage and out in the CDN and cache. We'll just give a different playlist to the right, that has the right chunks for the time zone you're in. And so that takes care of the time delay. So At 8 a.m., we've already transcoded those chunks. That's what we're showing those live. When PST comes around, it's going to get those same chunks, just at a different time. All right, and then for station localization. So to handle the localization, we wanted to use HLS ad replacement. And that's actually pretty straightforward. So the way this is set up, and I'll show a diagram of the whole thing, but basically we have a feed in our data center that's pulling in this video that we're broadcasting out to the internet. And at that feed source, we're inserting SCUDdy markers to basically mark the start and the end of those 65-second avails so that we can then trigger off those later on. So you have a cue out, cue in. Those basically are there in the feed. So now what that lets us do is, using those cues, we'll be able to theoretically show different content for different stations depending on where you're localized to. So maybe KQED is going to have their content there for that 65 seconds. WGBH will have their 65 seconds of content. And then maybe 13 doesn't want to bother doing anything, and so they'll just get the flow through of what was there at the that we are sending up in the main feed. And so the implementation for that ended up being Elemental using their Delta. We were already using the Elemental tools for getting the encoding done. And they have a product called Delta, which basically is an HLS packager. And so we basically decided to use that with a custom ad trafficker to, they're not really ads per se. They're usually 65 seconds of here's what's happening at your station or watch this program coming up. So we built, and so we'll come back to the ad trafficking thing. This is the initial piece that we launched with time delay. And so what we have here is on the far left, you've got our feed from PBS, which is going through a primary and a backup live encoder in our data center, which is going out to, basically that's just taking an RTMP stream and pushing that out to live encoders in the cloud. The live encoders in the cloud are actually set up with primary and backup, and we actually have primary and backup of each going to each in the cloud. So it's literally set up so we can, and those are going over different ISPs. So if we have an ISP go out, it will keep going. If one of the ground encoders goes out, it'll keep going. If one of the cloud encoders goes out, it'll keep going. The live encoder in the cloud does the encoding there, pushes that into Elemental Delta. Elemental Delta is taking that, and to begin with, all we did was we said we've got 5 output filters, I guess. I thought we had 6 time zones there. We are skipping Central on this slide. Apparently the Central time zone doesn't exist. So we had the output filters for each time zone. And then basically what we did then was we then created essentially aliases in front of that. So if you were localized to KQED, that was essentially an alias to the Pacific time zone feed. If you were WIDA, that was the Eastern time zone feed. And now we have, going out over our CDNs, we have the ability to see the right time delay for your video. So that's what we launched with initially. So then what we did was we had a couple of engineers spend a couple of months building what we call our Avail and Interstitial Manager. And what that is just a web app that allows the stations to log in and upload 65-second chunks of video, which you can now see down here at the bottom. They are putting that data in, and that data is essentially, in the admin, is being ingested into, again, an Elemental server in the cloud, but not a live server, just one of their encoding servers. It does the encoding of that content and essentially registers that VOD content with Delta to say, here's a chunk of video that is available to be played, and so on and so forth. So then what we did was then we put what they call ad replace output filters in front of those now. So now we can say, all right, WIDA and WGBH are fronting Eastern, but there's now a VAST call that happens at that 65-second chunk to call back in and say, what piece of video should I be watching? And it can then point to that piece of content in Delta and pull that out, and you have a seamless 65-second chunk of video there. Another neat thing we were able to do with Elemental Live was to also, I think the fallback actually goes from the primary server to the secondary server to a 4-hour chunk of VOD content that we had sitting in there that was sort of pre-approved. This is the 4 hours of wildcrats to show if something is really wrong on the ground or in the cloud. And then beyond that, the final piece was a 5-second, you're watching PBS Kids, and then it will loop back to the original. So if it ever failed over, and it has before, it would fail into that 4 hours of content, and then we could literally hit next. It goes to the 5-second, you're watching PBS Kids, and then loops back around to live, and it's back up and running. So that's the by and large, that's it. We're using Elemental Delta to do our dynamic HLS packaging. We have one robust fault-tolerant live stream that's dynamically time delayed, localized to each station, and we don't have to worry about 160 operational nightmares.